So we're talking about aerial imagery georeferencing. And the way georeferencing works is we align a raster with control points. Let's see if we can look at control points. Control points, I don't have a image here, but the way control points work is you have a points on a reference raster, and the reference raster is just, it could be something as simple as the imagery that loads automatically or streams from ArcGIS, or it could be something that you bring in. In this case, we're bringing in what's called NAIP, National Agricultural Inventory Program. It's something that the USDA uses to map cropland across the country. And so every so many years, they'll go out and do this aerial imagery survey, and then this imagery is actually georeferenced. So it's pretty high quality georeferencing, and that's what we'll use. And the idea of control point is you use the georeferencing tools, which we'll go over in a minute, to drop a point in a area that you can match between the two images. Let's see if I have Google Earth. Let's see. No, I don't have it installed here, never mind. Google Earth, you can do this. They have, sometimes for certain areas, you can use the go back in time feature on Google Earth and look at different times of aerial imagery that's already been georeferenced. And so that's the idea. And so we'll find matching points. It might be it's an intersection of a road. It could be a tree that you can identify between the two locations, a house, a corner of a house, something like that. And then you'll match those 2 points. And so you have to collect many points over an area and then transform the raster. And the idea of transforming the raster is you get this image and it's not georeferenced. And so it's got cells that don't have units associated with them, nor do they have a coordinate system. And by matching those points, you stretch that using either a linear equation or there's really complex ways to do it. But in the most basic sense, you create a linear relationship between the original image and then the mapped image based on those control points. And so Arc does that automatically for you. And you can choose what kind of equations you want to use. You can get it really complicated, like a spline that'll make it really warped. And that's good for really high accuracy for a small area. We're going to keep it simple and kind of just use what's called a first and second order polynomial. So once you do those control points, you can stretch it and then create it into a coordinate space and then export it as a raster that's georeferenced. So here's just a look at the different kinds of ways that we can stretch. The most simple way, which they call a affine, it's a first order polynomial. It's just first order just means we have X and Y. We don't square anything. And so that's going to either, you can twist it, you can rotate it, and then you can stretch it in the X and Y directions. Second order polynomials, you can actually fit, X plus A times X plus B times X squared plus C. And so now you've got a curve that you can fit, and so it can actually make it a curved fit. Third order, obviously, we have a cubic in here, and that things can get really complicated. The higher order the polynomial, if you ever go to do regression in Excel, you can basically keep adding polynomials to fit the data perfectly. So if you've got a data series that kind of looks like this and you put a 8th order polynomial in it, it can almost fit the data perfectly, but it's such a local fit. Anything outside of the data is going to be garbage. And so the higher orders you go, the fit's going to be better, meaning if you put a control point here and a control point here, they're going to line up really well between the two images because you can fit a really crazy equation to it. But anything outside of those control points is going to be really distorted. So that's one of the drawbacks. All right, let's take a look at our download here. Still zipping, getting ready to download. So now we've got this 1947 image in the map. Zoom to where you want to georeference. And then, so we've got Paradox Valley here. Go to Imagery, Georeference, and then Georeference tab. And then under Contents, click on this image that you want to georeference. So it's highlighted, and then do Fit to Display. And then it should pop into your image, your screen. But the key is to zoom to where you want to do the referencing. So zoom to Paradox Valley. So once we've brought the image into our map, we can click on Rotate. So we did Fit to Display. Now we can do Rotate. And then you can wheel it around. And so you can uncheck it and check it just to double check. And I'll give you a hint, the text will read correctly. So you can see it says 9:23:47. That'll read correctly if it's up. And so the way that that was oriented is that text means north. That text is on the north side. So rotate it around, and then it doesn't have to be perfect. Then you can do move. And then you can move this and kind of drag it so that it overlays a little bit. So if you want to zoom out, you can click on Scale, and then you can go like this. You can scale, rotate, and then move. And just get it ballpark, right? You just want it close enough. And then once you do that, just click out of there. And then you'll have your image. And then we'll save. So once you get to this point where everything's been kind of, close enough, let me know, and then we'll move on to the next one. So now we're going to add our control points. If you hover over this Add Control Point tool, you can see it says first click on a location on the source layer. So that's going to be the imagery in the background, the color imagery that you want to georeference to. Then click on the corresponding location on the reference layer. Let me just double check the source and reference layer because those terminologies are important. Actually, I have it in this document right here. If we go back to the okay, zoom in to see pixels. So we're going to find locations that match up. We'll do the Add Control Point. Okay, so first actually we click on the source image. The source image is going to be the image we want to georeference, and then we go back to the reference one. All right, so let's find a location that we can match up. And the way I'm going to do this is just kind of zoom in and out with my scroll key. Let's find this bridge. That's probably going to be something that stays the same. Now it looks like that bridge moved, so we can't use that. Let's use so I'm looking in this area. Let's see if we got something here. So we see where this kind of road Y's off. There's a little bit of a house right up there. I don't know if that's still there. Okay, how about some cottonwood trees? right here north of the road, we see some cottonwood trees that are growing. I see 1, 2, 3, 4, kind of just like this, like a little constellation. There's one right here on the corner. There's kind of like a little 3, 1, 2, 3, like that. And I see this. I'm going to pick this one right here and call it my corner tree. So that's going to be this tree right here. So add control point. From, and then now we got to go to. And I'm going to say that's my tree right there. So we just did 2 points. I clicked on the source, which is our gray image, and then I unchecked it and I clicked on the color image. So now it's going to shift it in a way that lines it up a lot better. I'm going to zoom into that tree again. You can see the channels moved quite a bit and narrowed quite a bit. If you mess it up, you can always right click, I think. Yeah, having a mouse with a scroll wheel is going to be more helpful. Okay, so I'm going to, you can do resets, or you can, let's see here, you can go to control point table, and then I think you can just delete a control point. Yeah, so if you go to the control point table, click on the row, and then here's this delete selected button. All right, so I'm gonna go ahead and add a few more control points, and just for the sake of time, I'm gonna walk through the rest of it, and then you guys can work on it on your own. So let's get rid of this. So I have a little more room to work with. The trees can work. If you can find some trees and make sure you have the right one, that can be a good way to do it. So I'm gonna go back to do some more trees because there's not many of them here. And I can see a cluster of trees a little bit further downstream, and then there's one by itself. And then I think that's the same cluster here. Here's the cluster of trees, and then here's one by itself. So I'm gonna go again, do add control points, zoom in, and zoom in as much as you can. Obviously, there's a lot of scale error here. Uncheck, and then zoom into this tree. I'm just going to try to get right in the middle there. You'll notice once you start adding control points, you can no longer use these fit to display, rotate, and scale. So once you get it lined up, you're kind of locked in. Of course, you can always start over, but hopefully you don't have to. Each time I make a control point, I'm going to save my map too. Ideally, you can, if you care about georeferencing the whole area, you can get points like 4 points on the whole edge, because you want to surround the area that you care about georeferencing by points. So I'm going to look over here to see if we can find something that matches up, maybe this intersection of the road or this tree. So here we have that road. I put my second one on another tree down here. I'm going to zoom up here to this road. And so I'm just going to say this intersection somewhere in the middle is going to be my next control point.
the control point.
How do you stop?
Yeah, because I want to be able to move my map.
Did you start a control point but didn't finish it?
Oh no, I finished the first one. But no, I'm trying to just move the map. And every time I go on it, it just wants to create a new point source.
Oh, what I'm doing is I'm using my scroll wheel to zoom in and out. You could always go back to map and do explore and then just drag it. But when in the georeferencing tab, once you do the add control point, it's got you over there. Okay, so I found one up here at the road up top. Let's see, there's a little farm or some sort of settling pond over here. Let's see if that still exists. It does. So I'm going to use this top corner of the settling pond. So I went over to the northeast side. And it's kind of hard because there's a lot of wiggle room here, but I'm going to just say the top corner of this road around the settling pond. Okay, so now I've got my area kind of surrounded. Let's see if we can find something down here.
So does the first page always have to be on the black and white image?
Yeah, so that's your source, and then the reference is the one underneath. So first click on the source image and then go underneath. All right, so here I see like a road and then a little creek going underneath it on the eastern side. You kind of want to find where two things intersect. Maybe it's a creek intersecting with a road or two roads intersecting. Here's where a road and another road intersect. Let's see if that exists. That's been kind of washed out, so that's no longer there. Things move over time, right? There's a fence line. Let's see if that exists. Nope, it's a new fence. Here we go. I got a creek crossing the road right here. This is on the southeast corner. So there's the road. Obviously the road's changed, right? It was probably like a dirt road. Now it's a highway, but we can still kind of try to get the middle line of the road and where that creek comes in. So there's the road, here's the creek. And each time I do a point, it shifts the image again. It's trying to optimize the two. I think that tree that I did, well, no, it looks like it's okay. Yeah, the trees lined up pretty well. So now I have 1, 2, 3, 4, 5. I'm going to go for 6 points. And I'm missing some stuff up here. There we go. I found a tree that lines up between the two. So this is kind of in the middle of the valley, right around here. There's a little bit of a ditch or a creek or something. And there's a tree right there. And you can see it's there again. Obviously it grew a little bit. Okay, and I'll zoom out just to give you the reference of where I've got these georeference points. So now I have 6, and I've got the valley pretty well covered. I might try to fill in a gap over here, or maybe near the river. I use aerial georeferencing to delineate river margins and how they change over time, and so I might do some more points near the river. Now that I have 6 points in there, I can click on the transform button or the transform icon under georeferencing. So go ahead and go to transform and click down, and it shows you the different options you have. So by default, we do first order polynomial. So that's just going to be y is equal to ax plus b. And that's going to scale it and rotate it. You can also do second order polynomial, and that requires at least 6 points. So under transform, the default is first order. I'm going to click on second order and see what happens. So on second order, you can see that it made it a little curvier. And what it also did is my residuals, which is my error, went to 0. So it stretched it in a way so all the points lined up perfectly. Let's go back to first order. If you go back to first order, it uncurves it and it gives you some error right here. So you can see that all my control points, it tried to fit it as best as it could. And here's your residual error. So you can use that to calculate your root mean square error. And so the last part of this is, or one of the last parts is doing the uncertainty. And so once you get at least 6 points, keep the first order polynomial in there and then do export control points. And it'll do it as a text file. So I'm just going to do that on my desktop. So do control points, save it. And then let's take a look at that. So it gives you a tab separated file. Doesn't give you any headers. So we need to interpret that. What it gives you is the X and Y coordinates. In this case, I think it's meters. We have to actually double check because your map scale is important. Or the coordinate system for your map. So the coordinate system for the map is, you can see map units as meters. So make sure your map units are in meters. And that way it'll give you your residuals in units of meters rather than coordinates or something like that. So if we compare these tables, I see. So what this table does is it just gives you the X and Y values from your source image and the X and Y values from your map coordinate system. And then you would have to calculate the differences between those two. Let's see here. There we go. Up here is the window that gives you the actual root mean square error. I think this is the only way that it shows it to you. But if you look at the forward one, that's the one that's going to be the biggest. And this gives you the root mean square error. So it takes all these different errors here and calculates the RMS. That's 6.2 meters. So it's going to have units of the linear units of your map. So that's the error basically between these two images that you georeferenced based on those 6 control points. If you go to the second order polynomial, that goes to 0 because it stretches it in a way that lines those points up perfectly. That doesn't mean that the error is 0 though, because you can see there's some distortion. So we'll stick for this exercise to the first order, which gives us, I think, a more realistic estimate of the error, plus or minus 6 meters in the X and Y direction. So that's that little window. Once we've done it, we can save our georeferencing, and then we can export this image. So just right click, data, export raster. Coordinate system, We'll just pick one. Let's see here. It assigns an X and Y cell value automatically. Why is it not letting me pick a coordinate system? Okay, I don't know what's going on with that. It's not letting me pick a coordinate system, but we saved, so we saved our georeferencing. I'm gonna just take a look and see if it did anything to the imagery to create a world file. I think it did, yeah. So when I saved it right here, what it did is it saved the georeferencing data that we need right here. It's this .twfx, and that's gonna have the information for the projection in there. And I can test that. I'm gonna just open a new map real quick and test that by bringing that image in and making sure it's georeferenced. So do map, add data. And there it is. It's georeferenced. So all I did is once I did my control points and I looked at the root mean square error, I just did save and it automatically saved that as a raster that's been, georeferenced and stretched and projected. So for the rest of the assignments, if you weren't able to keep up with all that, I apologize. Do at least 6 georeferencing points and then save it. And then there's some more questions about looking at the resolution and then the error analysis. So just take a look at that. All right. And when you're done, you can close it and all those points disappear. So I've recorded that and I'll post it. And